Alright, welcome to the last notes video for the semester. We're going to be talking about reaction rates, so what we can do to a chemical reaction in order to speed it up or slow it down. We will watch this video in class together, but this is a good video if you want to watch it ahead of time. Gives you some really good examples of ways to understand what we're about to see. So one way we can speed up the rate that a reaction happens is to increase the amount of surface area of the reactants that we are working with. So the more exposed area we have of that solid gives us more particles that are able to react. So if you have more exposed, more can react, so it's going to create a quicker reaction rate. So the example down there says like students traveling in less packs. We will talk about when I have little things down there like that. It has to do with that video. We'll talk about this when we get to class. But an example we have here is just to show you here is if I have one big piece of some solid, nothing specific here, but made up of particles. All the particles in red are what are exposed to the surface. So those are the ones that can react. So if I have a total of 20 particles inside of a piece. If it's one big piece, I have 14 particles that can react, but I have 6 on the inside that cannot. If I break it in half, now I have 16 particles that can react because now I've got more exposed area. If I break it down even further into 5 pieces, now all the particles can react. So that means that it's going to have a quicker reaction because they can all react initially. So example, again, we're going to look at the same examples in class, but of chalk and vinegar. If you, you can maybe predict what we'll be doing with that, but think about how we could maybe model how increasing surface area is going to speed up the process of chalk and vinegar reacting together. Another way that we can increase the reaction rate is to increase the temperature. The more temperature we have, the higher the temperature, the more energy there is, and then that energy is transferred to those particles, so they move faster. So that's one reason it increases our reaction rate, is they're moving faster, so they're going to collide more often. So as those particles collide, they react with each other, so they're going to react faster. So same concept as before is, if we're having things reacting more, then it's going to create an overall faster reaction rate. So another reason, so first off, they're going to collide more often with temperature, and a second thing is that they're going to collide with more energy, so that means it's going to break the bonds more easily. So if those particles, those compounds hit each other harder, essentially, with more energy, it's a lot more likely that chemical bond's going to break in order for them to react the way that they're supposed to. So particles moving faster, bonds breaking easier because they collide more, they collide with more energy. So both are going to wind up with a faster reaction rate. And we're going to look at that example with Alka-Seltzer and water. And again, that little note at the bottom has to do with our video we will watch. Another thing that is going to increase our reaction rate is to increase the concentration of whatever reactant we have. So the more you have of that object, the more you combine with the more reactants you combine, the quicker it's going to react. So higher the concentration compared to something that's diluted, again, if you have more particles, more are going to collide together, which is what is required for a reaction to happen. That's going to create a faster reaction rate. If you increase pressure for gases, again, the pressure is going to cause those particles to be closer. They're going to collide more, and then you have a faster reaction rate. So we're going to look at that with baking soda and vinegar. We're going to look at it with the reaction rate with that. Another thing you can do to increase the reaction rate of a chemical reaction is to add a catalyst. Basically, what a catalyst is a typical a lot of times we have enzymes we've talked about probably when you're in 7th grade, but enzymes that act as catalysts, they speed up reactions. But any substance that increases the reaction rate by lowering the activation energy of a reaction. So the activation energy of a reaction is how much energy is needed to start that reaction. So the catalyst basically makes it so that energy that's required is less. So it takes less effort for that reaction to get started. So We are going to be looking at yeast and hydrogen peroxide. Um, Yeast is going to be acting as our catalyst, and it's going to lower the amount of energy it takes to start the reaction so that it gets going faster.